Okay, here's example 8.1. You have this 300-pound block right here on this slope. It's on this 3, 4, 5 slope. It's got 100 pounds pushing up on it. So we have 300 pounds pushing down. And we know the coefficients of friction are mu sub s is 0.25 and mu sub k is 0.2. And we're supposed to determine whether the block is in equilibrium and find the value of that force. Okay, so what do we have? You're going to have a normal force going perpendicular to that, right? You have 300 pounds coming down here, and then you have 100 pounds coming off this way. So the question is friction going to be that direction or this direction? So all things being equal, is this thing going to slide down the hill or up the hill? Well, honestly, I don't know right off the bat. So the way I do these things is I'm going to reorient this like this. I'm going to make this my x and this my y. It just makes it a little easier for me. So at this point, right, we have 100 pounds going this way. We have 300 pounds coming off at this angle, right? So that means that you have, this is I'm going to call the w in the x direction, and this I'm going to call the w in the y direction, and you have a normal force. Okay, so let's do some basic things. If we do sum of the forces in y is equal to 0, that says that our normal force is equal to w in the y direction, right? So what is w in the y? Well, we have this triangle. We have this 3, 4, 5 triangle. So w in the y is going to be the 300 times 4/5, right, which ends up being equal to 240. And while we're at it, w in the x is going to be 300 times 3/5, which is going to be 180. Okay, so our normal force is equal to 240. Okay, so now this is equal to 180. So which direction is friction? So we have 100 pounds going in this direction. Sorry, this picture is kind of gut. And I have 180 pounds going in that direction. So all things, if it was left to its own devices, this thing would move to the left. So therefore, friction needs to be in that direction. Friction is there. Okay, so now the question is, are we moving or are we not moving? So what do we have? We have a net effect of how much? 80 pounds going that direction. And we have a weight coming in here and a normal force coming in there. So we have a friction force there. Well, what is a maximum friction that this thing can resist? Remember, F max is equal to mu sub s times normal, right? And mu sub is 0.25. And what is my normal force? It's 240. Okay, so my F max is, it's 60. No less than 60 pounds. Okay. So if I have 60 pounds going in that direction and I have 80 pounds going in this direction, what's going to happen? It's going to move. Okay, so once I'm moving, what do I know about my friction? Well, once I'm moving, my friction becomes my Fk, which is equal to mu sub k times normal. So it's equal to 0.2 times my normal force is 240. So my friction ends up being 48 pounds in that direction. And so that is my final answer. It is moving, and I have 48 pounds going off in that direction. So that's all that the question asks. But to me, I find a slightly more interesting thing of, hey, what happens if this 100 becomes 200? Okay, so now let's look at at this point, right? You have a force here. This is, again, we call this Wy. You have Wx. Well, I'll just put in what the actual number is. This ends up being, what is this, 180? This is 240. Now we change this to be 200 pounds there. And this is a normal force, right? So here I'm going to draw a line. We're working above that. So our normal force is what? It's equal to 240. That hasn't changed. Our F max is mu sub s times normal, right? Which is still 60. Okay, so now that's saying we can resist as much as 60 pounds in either direction. So which way is friction going to be going? Friction, in this case, needs to be going that way, right? Because you have 200 going this way, going to the right, so it needs to, this 180 needs some help. So therefore, my friction is what? Is it 60? No, it is 20. How do I know that my friction is 20? Well, it just comes down to so simple as saying sum of the forces in X is equal to 0. So in other words, 200 going in that direction needs to equal 200 going in that direction, right? And since we have 180, the difference is 20. So it's really easy to want to put down 60 for that friction force. What is that 60? Again, that 60 is the maximum that it could resist if it needed to. But in reality, for this problem, it only needs to resist 20 pounds because that's all that's left over. So, and that 20 pounds is in that direction, whereas the other problem, it's going uphill.